So I'm going to start, and I have a lot of slides, and the purpose really is just to illustrate the method of fuzzy set analysis. So I'll define it and give examples, and really my purpose isn't to give the whole detail, because it takes a little bit longer than half an hour or than 40 minutes. It takes a little bit more time. So I just wanted to give a flavor of different aspects of it. I hope that's going to be all right. I mean, to define fuzzy set analysis, I would say it's a mode of analyzing data using set membership and configuration analysis. Now, that definition is a little bit biased, and I have with me a book that might disagree. This is the book by Smithson and Verkulen in the SAGE series, and they would say it's more of a measurement metric method, which I don't take it as a measurement metric method only. I think that's a technocratic approach to social science, sort of construing it as a science, but to me it's more social. So I tend to see this method in the qualitative methods as a mode of analysis. So see what you think, and I'm ready to back up my opinion. I also brought a book by Charles Reagan, which I've put a picture of that in the slides. It's the book from the year 2000, and this is a really famous book, but it is getting a little bit out of date because his own idea about the methods have changed slightly. So in the slides I've put some other much more recent books which I would recommend you to buy, and they're also by Charles Reagan. Reagan says you can distinguish a necessary cause from a sufficient cause, and I'll go on about this and conclude on that topic today, but some statisticians say we cannot know whether anything is causal. And this idea that we cannot know, I find quite worrying. It's a kind of nihilism in epistemology, and I don't really support it. So you can see what you think, but whether you're convinced won't depend on what I say. It'll depend on what your epistemology is, whether you'll feel comfortable. I come from a realist orientation, so I have a very clear ontological point of view, and then epistemology drops out of that. But if you start with epistemology, then you might not be with me because you'd be not stressing ontology. So, gosh, there's a sort of preface that leads me to define fuzzy set in this way. A mode of analyzing some data using set memberships and configuration analysis. So what I'm going to do is introduce fuzzy sets as a measurement method first, because we all agree that it can be used as a measurement method. And then I'll give 3 reasons to use them in qualitative research. So I'm going to assume, in a way, that you've come thinking that it might be something for a qualitative or mixed methods researcher. And then I'll go into the mode of logic used in QCA. And that's quite happily used by quantitative as well as qualitative researchers. So that's where it gets a bit technical. And I did bring another document with me. I've brought a chapter in a book. And I'm just glancing through to show you that this chapter I wrote has examples of the actual fuzzy sets. So I just use them in the normal course. In the normal course of my research, I use spreadsheets for qualitative data, and I use scattergrams for qualitative. Those are labels on each point showing 2 or 3 items in these fuzzy sets. So it's an XY diagram of 2 fuzzy sets, and the spreadsheets have pseudonyms. So it was really a chapter meant to illustrate good practice in doing fuzzy sets. And this chapter is referred to in the slides. So there's a way there for you to follow up on what I'm going to say. So as I say, that's the outline of the talk. And I'll start off then with memberships in sets. Now, the idea of a set is the sort of Boolean idea. It's that you define something. So I'm going to use the morbid example of people being dead. I thought it might entertain you. And people being alive. So you have these 2 states, dead, alive. And I would argue that you could have a fuzzy set of that, because you could have degrees of deadness. And I regret it if it seems flippant. It's not meant at all in a flippant way. But that in health research, when someone's in a coma or in palliative care, we know, in fact, that they are near to the stage of being dead. And this idea of nearness is exactly what we capture in fuzzy sets, with a number between 0 and 1. So my slides show, can you see it? It shows 0 for living, 0.2 for suffering, 0.3 for damaged. We can imagine perhaps a cancer that's damaging the organs. 0.7 for incurable, 0.9 for palliative care only. And you might know that there's another state in hospitals where they say, do not resuscitate. They put a sign on the bed saying, do not resuscitate, and that's even beyond palliative care, and then dead. And the idea in fuzzy sets is really that anything greater than 0.5 is considered to be somewhat in the set, and then there's ordinal rankings of levels, and then we have the final state, or the complete membership in the set of being dead. And this actually would mean that you wouldn't have to have post-mortem data in order to look at how a treatment could help you to recover from an illness. Because instead of looking at recovery, we would look at reducing the risk of death in this fuzzy sense. So if the treatment had, increased the time before you reached incurable state, or if it had, stopped you at a certain state, which was not one that led toward death, so perhaps in the damaged state, then that would be an outcome. And we could study living bodies, living in the technical sense, not the fuzzy sense, and we wouldn't have to wait for people to reach the stage of postmortem. And so actually the example is based on my own knowledge about dementia and the way that some dementia studies are restricted in numbers by the fact that they have to wait until there's enough deaths of enough reported cases to get a body of material from the brains of the dead. And they can just as well now do the scans of the brains while they're living, while they're in hospitals, and there's many more thousands of people in that condition than there are people prepared to give the body for post-mortem examination. So it's quite a practical thing. No one's done a study like that, but the idea is that you calibrate the set around the 0.5 level. So your calibration decision, according to some people, it's a subjective decision. According to the broad school of QCA, it's an expert decision, and it needs to be done very carefully and scientifically in the sense of being transparent, because the 0.5 level would be considered both in and out of the set, and across different fuzzy sets, you would continue to use that baseline. That would mean we just don't know whether they're in or out. But the numbers 0.7, 0.9, they mean that we do know that they are somewhat in the set of Y. And I'll use the letter Y. So this example here is just depicting fuzzy sets as a measurement metric. But I've picked up on a different difficulty with them, and that is about individuals having a fuzzy set value. Here it's on the horizontal axis, versus households having a fuzzy set value. So here the households are on the left, and the individuals are on the right. The results are very similar, but actually if you scatter these two fuzzy sets, you don't find a complete correlation. This one represents, for slum dwellers in Chennai, India, how they feel over a panel of 1.5 years that their life went up or down. It's sort of a general satisfaction with their economic circumstances. And we've written a paper with the correct question wording, etc. They were interviewed every 6 months. For 3 interviews. So at the left, you see this huge number of people with a 0, which refers to going down, down, down in 2008-9. Their economic circumstances were felt to be deteriorating. And then there's a few who have actually a positive fuzzy set value greater than 0.5. That's these over here. And they are having up. So here's up, down, up, something, something, up, something, and this is up, up in all 3 periods, which was quite rare. So we were trying to study the recession. But India's experience wasn't just recession, and they didn't have a recession in the same way as here. So I'm just trying to show you an example where we take panel data, and it is subjective with recall, but carefully structured, and then we do data reduction with fuzzy sets to simplify. And now we can do a cross-sectional fuzzy set or QCA analysis. So I'll talk later about qualitative comparative analysis, but I did want to just really introduce you to fuzzy first. And fuzzy doesn't have just one meaning. So here's another meaning. Fuzzy set theory movement in social sciences, that was written in 1995. It's very popular. It's been growing and growing and growing. And this person, Treadwell, he interprets it slightly differently. He says it's a fuzzy logic conclusion is one that's not stated as either true or false, but as being possibly true to a certain degree. And please notice this is not probability. It's not in the probability discourse. The degree of certainty is called the truth value. Fuzzy set theory uses only the numeric interval 0 to 1. 0 means it's false, 1 means it's true, that they are in the fuzzy set, and all the values in between mean it's uncertain. So uncertainty is a term you find in complexity theory. And David Byrne, who I haven't shown you any of his books, but really there's a pile of 4 books by him that supports the use of fuzzy sets, broadly speaking. He would argue that it's good to recognize that some things are really uncertain and not just probabilistic, but if we knew more about a situation, we could give more parameters to our uncertainty, but we would still have some area of uncertainty. So it's like that in health, that you sometimes have miraculous recoveries and cures, which surprise everybody. And that's real uncertainty, not just error in a model. And so there is a discourse here about using fuzzy sets for uncertainty. Pierre Fiss has been using fuzzy sets to look at organizational strategy. And Pierfist has a paper recently. If you just Google his name, you'll get it. It's in one of the best journals in management organizations. And he argues that there are core causes and peripheral causes. So Pierfist, like Byrne and Reagan, so I have two sides now. The people who believe that we can know about causes discern all kinds of aspects of causality. And his idea that there are peripheral causes which maybe disrupt our understanding in statistical modeling, he says, well, that's an established view. It's very well established that this is the case, but also it's an empirical question. Which things are peripheral and which are core? So he says, let's use fuzzy sets to discern better which are peripheral and which are core to a given outcome. Cooper, another person looking at education, he actually uses continuous variables like the years of education and the income of a household, and looks at class mobility. So here, Cooper would convert the continuous variable to a fuzzy set scale by calibrating it around this 0.5 level. And he says fuzzy sets offer a better mode of argument than continuous measurement. So that's really interesting because he had continuous data, so he's competing directly with statisticians who, I think in many ways, statisticians have excellent ways of looking at these large data sets. So, nothing I say would imply that statisticians don't do a really good job. But the question is whether fuzzy sets can compete in some way. And it's just competing in a completely different realm. So, for example, Byrne says, we're not talking about variables. We're talking about something else. We're talking about configurations where each group of cases that has a different set of characteristics may actually behave differently. And therefore, the meaning or the mechanism or liability of a certain characteristic, let's say X4, is different in one configuration than in the other. And this is complexity. This is also ontologically saying, well, we're not just universally deciding whether X4 causes Y, but we're saying how is X4's effect differentiated among the different groups that we have, and how do we discern the groups? So there's a lot more that's exploratory here, perhaps inductive rather than deductive, and it's non-universalistic. And that's all been explained by Dave Byrne. Here's another management application. Colin Talbot in the management school is very keen to use fuzzy set to look at things like outcomes for firms. So they already know that there are numerous causal factors for profit or for growth of the firm, and then they can classify them and measure them and go across 1,000 firms, or even just 40 firms, and then empirically study which ones were more important in getting the outcome. So they would fuzzify all these, and I'll be doing some workshops in the business school about fuzzification and QCA. So if anybody really wants some intense training in the next few months, there's some possibilities. So there's a sheet going around about some training that you can audit or attend for credit, and there's also these one-day workshops, which if you just ask me, I can ask permission for you to join in the one-day workshop, which would duplicate this, so you don't need both. Okay, Reagan himself did several applications, and I'll assume that you want to know what the applications are so that you would know whether your research could be done with fuzzy sets or how it could be done. So you can sort of pick one that's similar to your work. In this book, Fuzzy Set Social Science, he does country-level measures of protests against the IMF. So there's a whole literature on protest. I also have here a paper by Katz and Mahoney. Has anybody heard of Mahoney? And Matthias von Hau, who used to work here. This is explaining the Great Reversal in Spanish America. And this, as well as Reagan, used the country as the unit and then the features of the country. And that's been contested. If you look at China, it's not just one country. It has this complex history of regions. And so one hesitates to put China in those studies. But nevertheless, that work has been done, and it's very controversial. And Mahoney tends to support the view that we do know about causes, but we need to make it an empirical question how these causes work. Mahoney has a really interesting paper about nominal and ordinal causality, and he contrasts those two, which is what I'm doing, with narrative causality. And I think he makes a mistake in the phrase. It's really narrative interpretations of causality. But it's a good paper. Reagan also looked at IQs, so he challenged the standard bell curve interpretation of IQ, and he's looked at the breakdown of democracy in the interwar period. That example is in the books which are more recent. So we have Redesigning Social Inquiry. That's probably the best book just by Reagan, dated 2009. And there's also a book by Ryu and Reagan. So at the end, I'll give you the references. And it makes a fuzzy set of the breakdown of democracy. If you remember Italy and Germany, moving from democratic to totalitarian government. So those are cases where, yes, fuzzy is one, there was a breakdown, versus query Belgium and France, and perhaps the UK retained its democracy. Yeah, and so then you have causal factors. And you can see how it gets a bit tendentious or controversial, because some people would say the UK still wasn't a democracy in wartime, but it had some of the structures of a typical representative democracy, so it is widely considered to have continued as a democracy. And people have also questioned the falsification that's been used there. But to me, questioning it is good. It means that we're being scientific and we're ready to take queries and rerun it. So we in the classroom, we've rerun a lot of the data analysis that's done in here. And we certainly tend to reproduce the findings that Reagan had, which you can diagram them sort of like that. You have some X's on the left and a Y on the right, and all the countries are thrown in. I think he has a total of 57, but that's not all the countries in the world, and it's not a random sample. It's 37 that didn't have IMF protests and another 20 or so that did have IMF protests. So it seems a bit of an arbitrary choice of countries and definitely not a random sample. You can rework their model, because we can put this data into software and develop different interpretations of it. I then ran a model of growth, because I thought, well, let's take something really economic and let's see if we fuzzify the variables, would we then reproduce the kind of findings that economists do get about growth? And certainly it reproduces exactly what you'd expect. The usual pathways, the overall government spending is high where growth is high, and we had a 10-year gap between the date of reporting of X and the date of reporting of Y. And we did have panel data, so it was quite an extensive study. Foreign direct investment and liberalization contributed, and these are partly independent pathways in QCA, or in qualitative comparative analysis. Whereas in statistics, everything has to be seen as working in conjunction, sort of simultaneously. And that would mean that all countries would have a level of liberalization. And that we don't think that's really the way it works. So liberalization could help to produce growth in some countries, in some time periods, and it may not have in others. And it becomes an empirical question with this. So that's an image showing the growth model that resulted. And a lot of things dropped out of it. So in political economy, you get more complex models. In economics, capitalism, right, only with capitalist countries, it does simplify. And this idea of simplification was presented by Reagan in 4 books previous to 2000. He calls it limited diversity. So limited diversity is the claim that in the current modern, very unequal capitalist societies, we tend to reproduce the same patterns. And so people are not randomly thrown around the IQ spectrum. They're thrown around the IQ test performance according to social class and past learning experiences. So that really helps us to understand, and it helps simplify data analysis, because really you have some very good performers and some very bad performers. You don't have all different possible types. Every permutation of these factors isn't found in society. There's only a limited range of them found. We then tested A-level results. We looked at GCSEs as well, and we found that social deprivation sometimes inhibits the school results. Being in a selective school in some configurations is very helpful for high school results. And here we don't just attribute causality to these known factors, because we know that these are proxies for other causal factors. So the kind of families that send their kids to selective schools in Britain, the family itself and its learning behaviors is probably the real cause of the learning. And I think that's what the statisticians have been saying, is they're saying we should always be skeptical about attributing causes to, here's the model for school performance. So I'll just show you what some of these are. Socially deprived areas have lower school performance, but do we attribute it to the deprivation? No, you have to be very careful and try and work out what is it about the deprived areas that has caused these kids to perform badly. It could be that they are disobeying the teacher and starting the exam late. So then that's lateness. That's not bad. And you could have lateness in the non-deprived area. Selected intakes, comprehensive, Catholic schools. Each one of these has to be really probed and unpicked, and that is what I call qualitative research. It's also historical. So I stand then in the substantive historical school represented by Stockpole and other really famous authors who have been challenged by statisticians. In the SAGE volume by Smithson and Verkulen, they give more details about measurement, and they actually think of it as a cardinal measure. So the cardinality of it is that it's on a continuous scale. So when we make several fuzzies, we can then compare them, and we can make exact comparisons. We can subtract them and add them, and that's true. We can also transform things. So here is a formula, a kind of note that you can have GDP per capita, which is a continuous scale, and you can put that on a fuzzy scale. So you might say, well, $2 a day, so $700 a year per capita per annum would be our 0.5 calibration point. And then anything above that would stretch out up to 1. And then anything below that would stretch out down to 0. So that would be high income versus poor or low income. And it's basically, the calibrated fuzzy set is a monotonic transformation of the original income figures. And I'm going to show you an example where this is done in substantive sociology. Those are just the references that I've been referring to, notably that one. Excuse me. The example is depicted here. So this depiction is not what you really expect. They've just taken some countries in South America, and this is Katz and Mahoney and Howe. This is GDP per capita here. So these are the four ones. And they take the first country, second country, third, fourth, they've ranked them according to their incomes. And they've set the fuzzy up and made the transformation. And the statistical measure is this thin line, and the fuzzy is that line. So they're quite similar, really. But this jump here, this is a jump in the fuzzy, where the cases are going up rather rapidly above the fuzzy value of 0.5. We're trying really to avoid that value and to understand and be clear about what counts as an economically developed country. And then they use that scale rather than that one in the fuzzy analysis. Their fuzzy analysis has other variables also on fuzzy set scales. So there isn't time for me to, depict the whole study. If you like that one, then I'll give you the reference here by Katz. But the truth table now doesn't show the GDP fuzzy set. It shows some political ones: strong liberals, labor-intensive estates, having a dense indigenous population. And here we have the whole population of countries. So I quite like this study. I like it a lot, and it came up with really clear results. There's the result. Very simple finding, but arising from some technical machinations with those 6 variables. This shows that the liberal strength in the country historically, in the 19th century especially, was important for GDP per capita. In the later period, it's 1990. And this GDP has this as a necessary cause. So what we have here is a triangular shape. The triangular shape is a typical illustration and evidence of the necessity of X for Y in an XY diagram. So I've put a triangle over it just to try and illustrate that. And now, can I just step back a little bit to unpick what's happened here? Because I find myself very convinced by this clear result, but one could question whether it's right to have the fuzzy sets considered to be comparable. That's the big issue. Is it really comparable? And some scientists would question having any subjective element. Now, in my view, which I'm going to put clearly on a slide in a minute, is that if we had expert opinions applied and there was a consensus, then that would be quite a good way of arranging some fuzzy sets that are comparable. But if it is just an individual's personal opinion and not well informed, then that would be unscientific. So this is done scientifically, and there's 3 authors, and there's a big project. Going back a bit further, we can also realize that there is a whole mathematics here. So with respect, you can't take all this in, but fuzzy sets have rules. And with the rules, you can take a table of data like that one, and you can start combining the fuzzy sets. So you could ask, well, which countries had dense indigenous populations and strong liberal parties? And put the 2 together. And the maths for that is in one of these previous slides there. Commutativity, associativity, and actually what's really key here is that you can take the union and the intersection of these sets. So I did say it might get technical. And I found this really unfamiliar to me when I first came across it, but I slowly got used to it. So I've put some of the key points in the slide. The idea of the union is that you could have, is it the case that they were either this or this? Well, in that case, it would be the union of the 2 sets and the higher of the 2 numbers. But really what we want here, if we want to ask, is a country both densely indigenous and strong liberal, we want the intersection. So the intersection is depicted in a little formula here. It says A intersect B. And you take the minimum of sets A and B. It uses the minimum rule of selecting the smaller of the 2 elements. So it's quite restrictive. And it does, the statisticians are right, it does depend on exactly how you scaled your fuzzies. The scaling really matters if you're going to take the minimum of 2 numbers across the whole range from 0 to 1. So I'll leave you with that Boolean algebra and just say this is being used all over the place. It's used in the Human Development Index. It's used in measures of human capabilities now in order to make measurements across a range of domains and then somehow average them. We take the intersection. And there's no need to be massively macro about this. You can do it for smaller areas. So there's a lot of work going on. Really, it's very interesting and to some extent a bit challenging. So I return then to this question of necessity. So I find that a very interesting pattern, which statistical analysis could not obtain. And statistics anyway would say the sample is too small. And in any case, it's not a sample. It is South America. So it's a complete population. So the shape tends to illustrate necessity. And the example has actually moved from the fuzzy set scale back to the actual GDP scale. And that, I think, is because they wanted it to be readable by anybody and not questioned, but the results would look the same in the fuzzy scales. And in the end, in this study, one factor dominated, which I've shown. But you can have a multiple factor X. You could have three things involved in that and depict that. And that's what I call a vector. So that word comes out of math. So I'll teach a little bit about that in the course. And I want to turn now to my second section, which is sort of, I've been writing about this for a while, and it's thoughts that I think are very important, but I'm not going to develop them a lot just now. The first point is that when you have small numbers and you don't have a random sample, it's not really sensible or realistic to do statistical inference. So please don't do it. Find something else to do. And one of the things you can do is this QCA. So in that sense, the talk isn't just about fuzzy set analysis, but about qualitative comparative analysis. And that's why I tend to teach the two things together in a collection. So for those at the back, you can have a copy of that sheet. The second point is that when you have the whole population, or if you had, let's say there's a study of all the basins that have watersheds in Nepal, big watersheds called basins, there's only about 19 of them, and then that's all of Nepal. So it's a population, but it's like a whole population which is part of a wider global population, and it's not a random sample. Well, then you need something different from statistical inference. You need to be able to say, well, what was it about Nepal that was essentially the reason for the success of irrigation there? And why was some a failure? And then we can start to ask, well, if we go to India, if we go to Mexico, do we find the same characteristics? So I think these are situations where it's nice to use fuzzy sets. The third is you can use expert interviews or stakeholder analysis to get your fuzzy sets. So you don't have to make a subjective decision. You can involve other people in that, gather up lots of qualitative data, and then decide. And I've been developing examples about the Millennium Development Goal on clean water. So the supply of clean water in pipes is restricted among poor households, even if the supply is in the area, because they can't afford to buy the service. So it's usually charged. And it's also not taken up sometimes by middle-income groups because the supply is intermittent. And I've made some slides to sort of develop this. But the basic point is that in this sort of situation, it's not just a question of does the supply of water mean that people have got clean water. It's also that you're really asking in what circumstances does X, the supply of water, actually produce Y, which is people using clean water. It turns out you don't really need clean water for everything. You need clean water for key activities like drinking, and a lot of people are just buying that in a bottle. So then why should they purchase the stuff coming out of a tap? They can wash their clothes in rainwater, they can walk to the stream to collect water for something else. So sometimes you find that you get the water supply and nobody's demanding it. So there's some paradoxes here, and QCA is really good at unpicking what seems to be paradoxical and then finding out why it's happening. So we can look at water management. So that's an example that I want to develop. Some of the QCA concepts in this kind of scenario were necessary and sufficient cause. Do you remember I mentioned them at the start? And I need to finish soon, so I won't really go into detail on this part, but let me guarantee you that there are concepts in these works called the subset relation, S consistency, and N consistency. And they're separate measures of these two types of causality. So there's a measure of the triangular relationship that we saw here. That's necessary cause. And there's a measure of the other triangle, which is called the sufficient triangle. And it's claimed that if X is a subset of Y, then N consistency would be a good measure of how far X is necessary for Y. And this is where it gets into this Boolean math. So I've written out a formula in English. N consistency is the adjusted measure of the sum for all cases of the intersection of X with Y. But it has to be adjusted by the sum of all scores for Y. And for the other thing, the S consistency or measure of sufficiency, you just adjust by the X's. So the two things are quite closely related. And I do have an example for you, but also to reassure you that in this book chapter, there's a footnote that also contains the formula. So the whole thing sort of fits together and could be studied in a matter of, say, 3 hours, 3 to 4 hours of self-study. Footnote 1 gives the formulas for that slide. And that's the chapter in a different book. It's called, just show you the title on the chapter, Non-Nested and Nested Cases in a Socioeconomic Village Study. The reference is in this slide set, so we'll come to that. Okay, it's a chapter in the Handbook of Case-Based Research. So what I said was there are measures of necessary cause, and they're called consistency measures. Whoops, sorry, excuse me. We're nearly finished here. So I wanted to kind of illustrate a bit more about those. There. So there are measures of these. Necessity does appear. I've seen a number of cases now of necessity. Here's one where in female labor force participation, the whole national participation rate depends on the women. So the more the women of these countries participate in the labor force, the more the overall participation rate is. It's a necessity. So once you realize that, you realize how crucial the women are to the attempt to get productivity higher or GDP higher. Because if that was a constraint, then you just couldn't have a high GDP. So we also find sufficiency in natural data. But actually, the tests for sufficiency have raised more problematic issues. And basically, you sometimes have the failure of a test for sufficiency. So if you were just doing hypothesis testing, you'd say, oh, it didn't work. I got a rejection of my no hypothesis. Oh, no, an acceptance of my no hypothesis. So where would I go from there? And I just wanted to illustrate that for you. So this is with the data from India, and it's the best possible model of going up, up, up. And just check that. All the cases are dotted around here. No, going down. Sorry, going down is at the top, because most people have this deterioration. But there are some cases down here on the right. So X is neither sufficient nor necessary for Y. It's more mixed. And that's what I've been observing in microdata with large numbers of cases, is it's usually mixed. So you can make some adjustments and see where the bulk of the observations are. You can run this in Stata. You can run it in R. This is done on freeware. FSQCA software is free. So it's very simple, and it doesn't show the number of cases by enlarging these little dots, which is annoying. I've got 91 cases here. Actually, very few are down here. So really, X is sufficient for Y, but you have to put a number on it. So you put a number on it called the consistency level, and that can be done for each possible causal configuration. So the results are much more complex than they usually are in qualitative research. It's a whole different kind of qualitative research, and a lot of serious people are moving into this area in different disciplines. We do have a shortage of training in Britain, but we're better in Germany, Belgium, France. There are more training courses in other European countries than here. So I had one more example just to show you very briefly. It was in the Nepal irrigation context. Lamb and Ostrom. Ostrom won the Nobel Prize and was the co-author on this paper about the management of irrigation. There's the data set, very small n, and there's how you find the results. So you just go into a computer, run this little software package. It takes 10 minutes to reproduce the results they had, which had full consistency, that these 4 possibilities, there's 4 rows here, and the 4 together almost exhaust the sufficient causes of good irrigation. But boy, they engage in a whole, 20 pages of textual discussion of why their measure of good irrigation was not the standard measure, because they really looked into it, and why these 4 causes are they're not just one. It's because the configurations work in different ways. And that's actually the output from the freeware, from FSQCA. So for me, that freeware has been sufficient for all my research. I haven't had to use the fuzzy in Stata yet, or the fuzzy in R. And I understand they have slightly different algorithms, but basically the results will be the same. So just to conclude, the fuzzy set membership functions mean different things depending on the discourse of the researcher, really on the context of that discussion about the topic. Their use in configurational analysis and among realists like me tends to be to interpret pathways of causality. That's how we tend to work. So that was 4 pathways. There was the one with A and R and C. Then there was not A, with some other things and C. So if you didn't have A, you needed C. Then there was A and R and F but not L. And there it didn't matter about C, and so on. So you learn to read these, and then you realize you've tapped into quite expert, detailed knowledge. The empiricist problem, which is this sort of school, is that with the sufficiency level being high, you sometimes get low coverage. So you could have high sufficiency, but only have 50% of the cases covered by the explanation. And they would say, well, that's awful. You've not explained anything for the other half. And that has indeed happened to me. But one has to also look quite closely at what's happening, because that's reality. So in statistics, it's called error. But in this approach that I'm using, we call it information. We've learned more about the world. We've gathered up the raw evidence. And then the errors or unexplained bits in the QCA output are information about what was not explicable. And you need to look for an explanation. I can give you examples where that's worked really well. In the school example, we went back to look at Ofsted reports, and we found that some of the errors or unexplained cases, they had peer mentoring in the high schools. And peer mentoring now is really famous in Britain. It's come as an innovation that started in America. It's popular, it works, it's shown to have higher grades attached to it. And we had already found that in QCA. So that's good. That means our science is working, the method is working. We call it a generative approach and a complexity-based approach, but that involves dabbling a little bit in the theory of methods. The necessary cause shape differs from the sufficient cause shape. I hope you've picked that up, that you can do your XY graphs and really look at them. And there are many, many published applications. There's at least 300 articles just using QCA. Most of them, about half use fuzzy QCA. The other half just use the 0-1 sets. So that was all I wanted to say. I do have a slide there about how to get more involved. So you could go on a website, Compass. There's 3 S's in it, compass.org. Or you can join the GISC mail that I've set up. And we have like a small email circulation. It's not very busy. It's not annoying. But every month or so, training goes on there. There is a shortage of training. Or you can follow up these links to read more from my work. And I have some references. So what I suggest is these slides will go on the web. And, at Methods at Manchester.